Okay, so today we're talking about functions that are increasing or decreasing. Okay, let's start with that. That's a really simple thing. Is this function generally increasing or generally decreasing? Increasing. You read from left to right, correct? So if you look at this thing, generally it's going up. Now, is it actually increasing all the time? No. So what we do is we divide it up into parts and we say, this part right here, that's increasing until it hits something. All right, so now, this is all about the x's. It came from over here, and it kept working, it kept increasing until it hit there. How would I say it was increasing between what and what? Well, if I'm on the x-axis line here, and I'm talking about this right here, this function right here was increasing until it hit that. That's not 0 then. It's until x hit -1. That spot right there. Would you agree that that spot right there is -1, comma 0? Do you get that? Okay, so then this function was increasing between -infinity and -1. Now you could actually argue about whether it's actually increasing at -1 or if it stopped increasing right there, and therefore brackets versus parentheses. But on all today's answers, you can just use parentheses around everything. Can't have brackets around infinity ever, so just use parentheses on everything, okay? So that is increasing between -infinity and -1. Then it starts to decrease for a while. Then it picks up right here. And do you get it increases the whole rest of the time? Even that spot isn't like, it didn't ever start decreasing. So it's increasing that whole time. And so from here to infinity, it was increasing again. And I'm going to call that from about 0.5 to infinity, it was increasing again. There was only one tiny little spot where it was decreasing, and that I will do in blue here, right here. It was decreasing in that little zone from here to here on the x-axis, which is from like -1 to -0.5 or so. So the only decreasing interval was from -1 to -0.5. Remember I was saying you could use parentheses around all of these things. Okay, that's increasing, decreasing. Now I'm going to give you one. I want you to see if you could handle telling me this black graph here. Tell me where it's increasing. Remember, you're telling me x numbers. Put it in parentheses with a comma. Turn it my way and I'll tell you if you did it right. It's okay if you're wrong. The only thing that's not okay is not trying. Let me check now, make sure I know what the right answer is. Remember, it's x numbers. Yes, 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 yes. 3 people have figured it out. 4 people, 5, 6 people. 7, 8 people, 9, 10. Nope, thank you for trying. It's the x numbers, and it goes from 1 to something, but not what you said. Yes, that's right. Did you put in 2? I only want one place, that one little spot in the black graph. There's only one spot it's increasing. Yes, yes. 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 Okay, good. So it's increasing in this little zone right here, right? And what's that from? From here to here on the x-axis. It's only the x numbers we care about. So it's increasing between 1 and 3. Make sense? Okay, now tell me where it's decreasing. There's 2 intervals where it's decreasing. And I'll give you a hint. The first one starts with -infinity to something. That's this part right here. It's decreasing that whole time. So you'd say it's decreasing from -infinity until it hit what? And these are on the x-axis here. Until it hit what? There's 2 spots. Yes, yes, yes. And always use parentheses though. Yes. Yup. 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 I think you're all getting it right. So it's from -infinity to 1. And then it starts increasing or decreasing again at 3. And a lot of people say 3 to -infinity. Do you get why? Because it's going down, but it's not right. It's from 3 to infinity. We're on the x-axis here. So it's from 3 to infinity is your other one. 3 to infinity and negative infinity to 1. Those are your two little zones here and here where it was decreasing. All right. Now, what do we call these spots? This is obviously an important spot then, right? It's called a high spot, but there's an official name for it. Anyone want to take a guess? Fancy math word for high spot. Maximum. Good. And therefore, what do you think this spot's called? Minimum. Good. And locally, they are a maximum. But do you get how this spot right here is not the highest of them all on this function? It goes past that later. But it's called a local maximum then, because locally it's the high spot. But it's not the highest of all this function. This function goes on to higher spots later. In fact, it never even stops. So this thing has no absolute maximum, but this is a local maximum. And therefore that's called a local what? Minimum. Okay? And the local maximums and the local minimums are the extreme spots in their neighborhood. They're like the highest spot in the neighborhood or the lowest spot in the neighborhood. Which do you think you want to live in when there's a rainstorm? The highest spot in the neighborhood. Because if you've ever been living in the lowest spot in the neighborhood, all the water runs there and it goes in your basement. And it's true. A lot of people have that situation. And if you got special pumps built into your house, sometimes it works out okay because you could pump it out. Yeah, that's what a sump pump does. And pretty much everybody's basement is a local minimum. It's a low spot because it's lower than your backyard, right? Probably. Unless you don't have a basement. There's a few houses around Minnetonka that don't have a basement. Most people have a basement. Anyway, so you have a local minimum, but around your neighborhood, if you're the lowest spot of them all, then you're the absolute minimum. You're the absolute lowest spot. That's the worst because then everybody else's water that they're pumping out of their basement runs down the hillside and ends up in the lowest spot in the neighborhood, maybe your house. What's really best is if there's just like a pond, because then that's the lowest of them all, and usually the water runs down into that instead of your basement. All right. So this spot's called what now? Local max. What's this spot called? Local min. The absolute max, there is none. No absolute max because it goes up forever. And this one goes down forever, so there's no absolute min. Let me show you one that does have an absolute max or an absolute min. Let's say the function goes down like this, has a low spot, goes down again, has another lower spot, but then keeps going up forever. Is this a local minimum? Yes. In its neighborhood, it's the low spot. Is this a local minimum? Yes. There can be two local minimums. But that local minimum right here is also the lowest spot of them all. So it's not only the local minimum, it's called the absolute minimum, meaning it's the lowest the function ever goes. Okay, so this can be both. A lot of people get confused by that. Is it still a local minimum? Yeah, it's the lowest spot in the neighborhood, and it's the lowest spot of them all. So this is both a local min, and it's also an absolute min. So if this is a high spot, is it the highest spot of them all? No. It's like in the neighborhood, this guy is the smallest guy, or sorry, the strongest guy in his neighborhood. You know, you could be the strongest kid at Minnetonka. And you might not be the strongest kid of them all, but you might be the strongest one in Minnetonka. There's a kid in Orono, where my kids go to school. I'm going to pause so that I don't put anything inappropriate out onto the internet here. Okay, so that's locally the strongest, but would that be the highest of them all? No, because this graph keeps going up, so somewhere else there's some place that's higher, and therefore that's not an absolute max spot, that's a local maximum. All right, so if I look at one more, where do I have a good graph? I think I've used up all my good graphs. Okay, fine. I'll pull in another one. You know what? I think we talked enough about local maxes and mins, and I think that's a pretty easy part. So let's get on to the part that is the harder part, and that is taking not a graph, but an equation, and then putting it into the calculator and figuring out where it's increasing or decreasing or constant. And by the way, if it's not increasing, you know, the graph's increasing, now it's decreasing, now it's increasing. How do you do constant? It's just flat like this. Can you still be a function and be flat? Yes. Still passes the vertical line test, right? Okay, so this part's increasing. This part would be decreasing. This part would be increasing. And what was that last part? Constant, where it just goes flat. That's called constant. Okay, now let's grab your graphing calculators, and we're going to type a couple of these weird functions into your calculator and see what they look like. You're also going to really need to be good at Zoom Box. So graphing calc. If you need one, borrow one from me. Okay, so we're going to try graphing this right here. It's problem number 7 off your homework. If you want to actually open your homework up right now, that'd be totally okay. Why don't you go do that? Find today's worksheet. You got that shortcut on your iPad to get to the folder, right? And this one's called 1.2 point, let me double check it. I think it's 3, but yep, 1.2, worksheet 3. 1.2.3. And we're doing problem 7 right now. All right, so there's our graph. And it's got a little constant area. So now we can say, it asks in the directions. Tell where it's increasing, where it's decreasing, and where it's constant. I am totally fine with you abbreviating this and call it I for increasing. And it's increasing, let me go back and look again, between negative infinity and then, remember, we're on this axis here. We're doing only these kind of numbers. So it's coming from over here, so it comes from negative infinity and stops right there at what? No, that's not 2. Negative 2. There you go. Negative infinity until negative 2. It was that increasing or was that decreasing? That was decreasing all the time, wasn't it? Yeah, that was decreasing from negative infinity until it hit 2. Then it was constant. You can abbreviate that with a C if you want. It was constant from negative 2 until what? No, that's not positive. There you go. From negative 2 until 1. Remember, you can always just use parentheses on these. Don't overthink that. And then, of course, it's increasing from then on. All right. I want to do another one that's really weird looking so that you know what to do. Look at number 12. Everybody look at the problem 12. I'm going to drag it over here. There it is. Okay. Now, when you type this in on your calculator, remember to put a little parenthesis around that. Otherwise, your calculator would think you mean 5 divided by x. And then subtract 3. You know what I mean? There's a difference. So if you don't have a parenthesis in there, it won't work right. So everybody try to type that thing in. 1 divided by x. Yeah, it looks really weird. 1 divided by x plus. I'm just going to delete out a bunch of this stuff. 5 divided by parentheses x minus 3. Woo. And there's all kinds of asymptotes running around in this graph. And I want to show you what I mean. Asymptotes are lines you can never cross. And there's an asymptote line running here. And that means that the line, that this function will never touch 0. All right. And then there's another asymptote line right here. I was off a little bit, but I meant that to be at like 3. So if I could just move that. Yeah, there we go. There's another asymptote line right about there. Okay. So now, how do I answer the question? Well, it's increasing, decreasing, and constant. There are no constant parts on this graph, so that's, at least that's good. We got increasings and decreasings though. Or is it only decreasing? Where is it increasing? It's not. It's never increasing, which is weird. It goes down and then it starts over again at the top. It goes down and then it starts over again at the top. See what I mean? This thing's decreasing the whole time. It's only got decreasing parts. So where is it decreasing? It's decreasing from negative infinity way over there. I better use a different color. From way over here all the way until it hits what? Nope. 0. From from negative infinity until 0, it was decreasing, and then it starts over again. And it starts over again and starts decreasing again from 0 to, where does it stop? That other dotted line. 3. And then last, it starts decreasing again at 3 and keeps going until, there we go. Those are all decreasing. I know it's weird to think of something that only decreases, but yet has high spots. Yes. Good question. The way I wrote them, I wouldn't have to have union symbols. It's kind of cheating. But if they were all written along the same horizontal line, then yeah, we should have unions between them. So. All right. There's a couple of them. Some of these graphs will look really weird, but you'll just have to try to figure out, you know, when they look weird, is it increasing or decreasing? You can do that over any little piece of a graph. Just narrow it down to a little part. You know, on this one, for instance, if you were get confused, I'd hope you'd just look at this part right here. And just try to do that part and say, okay, well, what is it? That's decreasing. That's decreasing from, Server said it was only on the x's, so it's from negative infinity to 0. And then just think about the next little part and say, okay, well, on this little part right here it's like it's decreasing. Okay? All right. That's all you need for your homework for today. So that's all I have for the video.